So here we are in the printer plotter room, 4533. The 3D printers that we have in here, the first one I will point out is the Dremel. This is the Dremel Digilab 3D45. Manufactured by Dremel, a very name brand that we feel comfortable with, very reliable, and that's one of its great selling points. This print technology is FDM, fused deposition modeling. Some of its selling points, it has a self-leveling bed, which is really nice. A lot of the desktop printers do not provide that self-leveling bed. Here it is. A couple more of its selling points. Dremel does provide excellent customer service, and it's a very user-friendly system to run. You see that it has the easy to read icons, very simple to move through. Cost of this one is about $1,900. The print envelope, which is closed as you see, and that also is an attribute of this printer. The print envelope is 10 inches by 6 by 6.7 inches. So a nice healthy size build chamber. Materials, it's a 1.75 millimeter filament, and it will print. These are proprietary, so you do have to buy the Dremel cartridges. They do offer nylon and eco-friendly ABS and a PLA. We're currently running a PLA in that. The cost on that is $1 and a minimum of $1, and then 10 cents per gram for student prints. The precision of this printer is 50 to 300 microns, so again, it does have a nice precision. Some of its selling attributes, it does have just a single extruder head, which you can see in there. It has the self-leveling heated bed. You can use glue or tape in addition to help adhere the print. And it's very user-friendly with a micro SD card. So we'll just load this on there and away the job will go. Again, the printer can be moved around as needed, which is really nice to have that flexibility. The next printer is our 3D Systems 460. This is a unique printer. It's a powder binder printer. And what does that mean? Well, instead of using that filament that we've been seeing, it actually uses a gypsum-based powder. What happens is this arm will squeegee out essentially a really fine layer of powder, and then you've got a binder cartridge that will be sprayed down through a jet head onto the powder, and that will bind or fuse the build as you want it to be done. The bed will continue to recess, and you'll have your build built up essentially surrounded by loose powder. This is great because you can then recycle the powder. What you'll have happen is you'll vacuum out the excess powder, and you'll have your part. The excess powder will be reused, and then you'll actually put your part in here, and it will be blown. You take the airbrush and blow off the excess powder, and you'll have a nice, beautiful, clean part. Some of the additional attributes of this printer is it is a color jet print technology. So what you see here is actually an HP inkjet head, and so it has a software that comes along with it, which is referred to as 3D Sprint software that enables the user to color the model in software either by face, by entire part, or actually by kind of a very flexible brush. And you can get very complex colored parts like this one. So that's a really big attribute of this printer. We also pay for it. This overall is a $45,000 printer. We actually purchased it refurbished at $35,000. If you have been into the Maker Lab or the 4500 building, you will have seen our prior generation. This is the ZCorp 450. ZCorp was the prior corporation. 3D Systems purchased ZCorp. This is a printer that, unfortunately, the PC boards are no longer manufactured, and so this is kind of a skeleton, or a dinosaur, I should say, that is just for example, but also used for spare parts. So it has done a really great service for the department through the years. Some of the attributes, again, this is capability of being colored. The material, this powder, it's a natural product. It's gypsum based. It is proprietary, so they don't tell us the exact ingredients. Another attribute, again, is all the excess powder is recycled. The parts do need to be post-processed using cyanoacrylate. And what that is essentially a very viscous super glue. This is an infiltrant that you would essentially pour over your part, and it would soak into the part. The part is very chalky and very, very fragile when it comes out. And when you dip it or spray it or drip that infiltrant over it, it hardens up to be almost like a stone, a marble, and it makes for really beautiful architectural models like this one. This viscous material is about $150 a bottle. The material is very expensive too, so as one is gathering, this is a much more price prohibitive printing option, but it does have some real attributes to it. Cost on this machine is $3 per cubic inch, and it does print down to 100 to 300 micron precision. Some really good definition there, especially for the material. And it runs off a proprietary 3D Systems printware. And lastly, the workhorse of our Armada, and that is the 1200 SS ES. And this is an FDM, or fused deposition modeling printer, manufactured by Stratasys. And this actually was, Stratasys patented the first FDM technology, that fused deposition modeling, as well as the enclosed print chamber. So we did not see enclosed print chambers on printers across the industry until recently, just a few years ago, as a matter of fact. So here is that print chamber. This has one of the largest print envelopes in its class. It prints on a print bed, a print tray, and this tray is 10 by 10 inches. And in the Z, so that's the XY, in the Z, it's a 12-inch print parameter. So you've got a 10 by 10 by 12 envelope, quite large. This has a two-head extruder, and actually that head, that extruder assembly is actually it's a swivel head, and they claim that technology actually speeds up the printing process. It does use two materials. They are cartridges. This is an example of one. Obviously, these are proprietary. Here's the chip that it goes in, that goes into it. These are about $250 per cartridge, and they are an ABS plus, and then there's also a support material. And one of the benefits of this printer is it can either be a soluble support material or a breakaway material. So if you have a very, very complicated part, let's say a vent or something that has a lot of internal cavities and complexities, you can use that soluble support material to dissolve it. And we actually have a bath over here that the part, while it's still on the tray, would be dropped into, and there's a compound that's then added, and through agitation and heat and this, it's basically a sodium hydroxide material, you will dissolve the support material. So that's quite nice. The selling points, again, state-of-the-art consistency. This is a very, very precise, very reliable machine. This runs in the neighborhood of about $33,000 to $35,000. The cartridges, again, are that ABS plus, so it's a very strong material. It does run off a proprietary Stratasys printware, which is limited, but it is relatively intuitive. Precision is 100 to 130 micron. This for student printing is $3 per cubic inch, and probably one of the last benefits of this one is it does have an internal computer in it that stores print jobs. So you can send multiple jobs into the queue. They can be stored in this printer. Your computers can be shut down, and those jobs essentially can be run in order and stored for days on end. So that's really nice. In closing, I just wanted to point out the file types that all of these 3D printers use, and that is the STL. And that is standard tessellation language or standard triangulation language file types. And just about any file type, especially any CAD file type, can be converted into the STL quite readily. These printers can run off a number of other 3D friendly file types, but STL is really the gold standard. And so if you are considering 3D printing, I would recommend converting your model into an STL. We can talk about this in a later video, but I just wanted to give you that heads up. So thank you for bearing with me, and that was a quick overview of the various printers that we currently have in the Maker Lab.